And in this tutorial, we're going to be talking about how we can insert a node at a certain position within our doubly linked list. Alright, so to get started, you can see we have our doubly linked list here. And the only thing different that you might notice are these numbers on top of the nodes. And these numbers represent the position of each node. So this is position 1, 2, and 3. So what I want to do is be able to insert a new node within any position. And likewise, when we do that, there's always going to be test cases involved. So let's take a look at what would happen in case 1. So case 1 is going to be checking to see whether or not we're getting a valid position. So for example, if the position being passed in is less than 1, right? Because 1 is our starting point. So if I pass in 0, for instance, we are just going to ignore that. That's an invalid position. So any position that is less than 1, we're just going to return because it's an invalid position. Likewise, if the position that we want to insert a node is greater than the size plus 1, then it's also an invalid position. So for instance, if I want to insert at position 5, for example, well, the last node within our list is position 3. So in order to insert at position 5, I would have to create a dummy node and then create the node that's going to be inserted to position 5, which I don't want to do. So all I'm going to do is return in that instance. And if you're wondering why it's size plus 1, it's because if size, which will give me 3, plus 1, which is position 4, I could easily insert at position 4 by using the append method because we already have a pointer to position 3 by the tail. And then we could just make this node here point to the newly created node, and that would insert it at position 4. So that's why we check to see whether or not the position is less than 1 or if the position is greater than size plus 1. Alright, so from here, let's move on to case 2. What happens if the user wants to insert at the front of the list? So how can we test to see whether or not the position being passed in is in the front of the list? Well, if the position is equal to 1, we already know how to solve this problem. We could call the prepend method. And the prepend method will create the new node for us and insert it at position 1. It will also take into account that header will get updated to the proper new node that's being inserted. Likewise, if I was to move on to case 3, what happens if we want to add to the end of our list? So what do I mean by end? I'm not talking about position 3. I want to add a new node towards the back. So that would be position 4. So let's say I get position 4. How would I test this? Well, if the position being passed in is equal to size plus 1, so that will give me 4, that means I'm going to call the append method. And the append method is going to create the new node for us, and our tail pointer is going to be updated to the newly inserted node. Alright, so now let's move on to the last case. What happens if I want to insert between the first node and the last node? So for this example, since we only have one node that's between the first node and the last node, I want to insert at position 2. So how would I go about doing that? Well, the very first thing that I need to do in order to insert at position 2 is actually get a pointer to point to position 2. So in order to do that, we're going to create a temporary pointer that's going to point to whatever header is pointing to. Now from here, we need to traverse till we hit position 2. So now we're going to enter a for loop. So now within our for loop, all I want to do is advance what current is pointing to until we hit position 2. So now that we're in the for loop, let's execute it. So current is going to advance or point to current arrow next, which will get me here. And since this is a really small doubly linked list, we're only going to traverse one node. But if this was a bigger list, it would work all the same. So now we're at the position at which we want to insert our new node. So the first thing that we should do is actually create our new node that we want to insert within our doubly linked list. Alright, so from here, since we successfully created a new node, let's think of this logically. I want to insert n at position 2. So I need the previous node to point to n, just like it's pointing to position 2 right now. So in order to do that, what I can say is, since current is pointing to position 2 already, I could say current arrow POEV, which will give me this pointer, which points to this node. And now from here, I can access the next pointer by saying arrow next. Now, just to recap, I could say current arrow POEV will get me here. And then from here, I could say arrow next, and I can make this node point to n. So I can get something like this. Now, let's actually complete the link, because remember, this is a doubly linked list. Now I need n to point to position 1. So who has a pointer to position 1? Current does. So I could say current arrow POEV will get me to position 1. So now, from here, I could say n arrow POEV, which will get me here, is going to point to current arrow POEV. Alright, so from here, you can see that we completed the link between position 1 and n. So n is officially at position 2 at the moment. But what happened is I broke my linked list because n's next pointer is still null. So now 2 and 3 essentially don't exist anymore. So let's fix that. I want n arrow next to point to the previous second node within our linked list. And who has a pointer to the previous second node? Current does. So now from here, I could just say n arrow next, which will give me here, and make it point to current. Now from here, we're almost done. Remember, this is a doubly linked list. So each node needs a pointer to the next node and the previous node. So current, or the previous position 2, is still currently pointing to 1. It should be pointing to n though. So how will we go about fixing this? Well, since current is already pointing to the previous second position, I could say current arrow POEV, which will give me here, and just make it point to n, our newly inserted node that is the new position 2. Now from here, you can see that we've successfully inserted n to be the new position 2, and that our doubly linked list is still intact. So the last step to do is increment the size. Now from here, let's actually take a look at how we would write this in code. So from here, you can see we have our insert at method. It's not returning anything, so it's void. And we're passing in 2 parameters. So the first parameter is the position, where we want to insert the newly created node. And the second parameter is the data. And this is going to be used to create our new node. So let's take a look at case 1. Check to see if it's a valid position. So I'm just going to come down here. And remember, we start at position 1. So any position that is less than 1 is an invalid position. So I'm just going to say if the position is less than 1, or if the position is greater than size plus 1. And the reason for this is if it's greater than size plus 1, in order to insert it at that position, I'm going to have to create a bunch of dummy nodes in order to achieve that. And I don't want to do that. So that's why if the position is less than 1, or if the position is greater than size plus 1, all we're going to do is return. It's not a valid position. Next, case 2 says check if insertion is at the beginning of the list. So how can I test if the position is at the beginning of the list? Well, that's pretty simplistic. I could just come down here. If the position is equal to 1, what do I want to do in this case? Well, I just want to prepend to our doubly linked list. So now let's move on to case 3. Check if insertion is at the end of the list. So how can I check to see whether or not I want to insert at the end of the list? Well, size has the number of nodes within our doubly linked list. So size plus 1 is going to be 1 more than the number of nodes within our list. And that can easily be accomplished by using the append method. So I'm just going to say if the position is equal to size plus 1. That means all we want to do is append to our doubly linked list. So before I move on to case 4, I actually want to change these if statements to else if statements. So else if and else if here. So case 4 says if the position is in the beginning or the end of the list. Now I could probably get away with an else statement, but just to triple check, I'm going to use an else if statement. So I'm just going to make sure that the list is not empty. So I'm just going to say else if header does not equal to null. Now, the first thing that we should do if we want to insert a new node is probably create it. So I'm just going to say node start n is equal to new node, and we're going to pass in data. The second step is I should probably create a temporary pointer that points to where header is pointing to. So that's our starting position. Now what I need to do is actually traverse the list until we hit the position that we want to insert at. So I'm just going to use a for loop. And all this loop is responsible for is to keep advancing our current pointer until we hit position. All right, so from here, once we get kicked out of this loop, current is going to be pointing to the position that we want to insert at. So the first step that I want to do is make the previous node point to n. So now I'm just going to come down here. I'm going to say current arrow poev is going to give me the previous node. Now, how do I make this node that I'm currently pointing to point to n? Well, I can access the next pointer in it, and I can make it point to n. Now from here, I need n to now point to current. So now I can say n arrow poev is going to point to current arrow poev. So now I've completed the link between current arrow poev and n. So now what I want to do is make n point to what current is pointing to, because current is pointing to the previous node that held that position. And the last step, dealing with pointers, is make current point to n. So now I can say current arrow poev is going to point to n. And that would complete the link between these two nodes. So I'm just going to separate it. So these two nodes are pointing to each other, and now these two nodes are pointing to each other. And the last step, since we successfully inserted a node, increment the size. So now I'm just going to save this. And I am going to go down to our main method. You can see that we've inserted 5 nodes here, and we're inserting at position 3 the number 20. So now I'm just going to bring up the terminal. I'm just going to go to my desktop. Let's compile. And it looks like I made a mistake. I said int is equal to 1, which is not true. So let's actually declare our int I is going to be assigned a value of 1. So let's recompile. And it seems that I forgot a pointer here. Well, today is not my day. Recompile 236. And I forgot a semicolon here. So now let's recompile for the millionth time and let's run it. And you can see that we do successfully insert 20 at position 3. So anyway, that wraps it up for our insert at method for our doubly linked list.